I want you to imagine this case. We take the same ramp, and we're going to race 5 different objects down the ramp. So here's one of our objects. A hoop or a ring. Here's the other object. A solid disc. Here's another object. A solid sphere. Here's a 4th object. A hollow sphere. And then the 5th object, I want you to imagine, is, we'll take a really heavy block, and then we'll put some very tiny wheels that hardly add any mass to it at all, and we'll imagine the case where the bearings in these wheels are just really, really like grease lightning, right? Essentially, we're imagining a case where there's no friction at all for this block that's going to go down the incline, and all of the mass, 99.9% of the mass, is in the block itself, and so the wheels have such low mass that we can disregard them. Okay. 1, 2, 3, 4, 5. Which one wins the race? Can you rank them in order? After thinking about it, why don't you press pause and see if you can predict and rank from greatest to least which one has the greatest velocity, and therefore which one gets to the bottom in the least amount of time. Rank them in order. Press pause and give it a shot. Okay, so welcome back. Let's make a grid to summarize. So the different objects are the cart, and then the solid sphere, and then the solid disc, and then how about the hollow sphere, and then the last one we're left with is the, let's do, how about, oh, no, there's only one more left, the hollow cylinder, or the hoop, or the ring, or whatever you like to call it. Okay. Now let's add some columns to this chart. And in the middle column, why don't we write down what the formula is for the rotational inertia? Well, it doesn't apply for the cart because the cart isn't going to tumble and roll. The wheels will, but remember, the wheels have such low mass compared to the mass of the whole block that it's negligible. Okay, now for the solid sphere, we know I is equal to 2/5 mr squared. For the solid disc, 1/2 mr squared. For the hollow sphere, 2/3 mr squared. And for the hollow cylinder, just mr squared. And then in the last column, what does V equal? So we already solved 2 of these for the solid sphere. V is the square root of 10/7 GH. For the solid disc, V is the square root of 6/5 GH. Now for the cart, we already know this one. We've done this example so many times. It's just the square root of 2GH, right? Same thing as instead of saying a cart, we could have imagined an ice block. Just something that converts gravitational potential energy strictly into translation without any rotation. So we end up with mgh is 1/2 mv squared. M's cancel, and you can see it. V would be the square root of 2gh. Okay, so then we have 2 more to solve for, the hollow sphere and the hollow cylinder. So in every case, we get this statement, mgh, the gravitational potential energy, converts to translational kinetic energy plus rotational kinetic energy, 1/2 I omega squared, and we're always going to substitute V over R for omega. And in fact, in every case, we're going to have some constant multiplied by mr squared. Sometimes the constant is 2/5. Sometimes the constant is 2/3. Sometimes the constant is 1. But it's just some constant, right? 2/3, 1/2, 2/5, 1, etc. So M cancels out in every case. the r cancels out, and we have is GH is equal to 1/2 plus C over 2, and then the V squared factors out. So V is equal to the square root of GH, 2GH over 1 plus C, right? We can combine and say this is the same thing as 1 plus C over 2. So if we multiply both sides of the equation by 2 over 1 plus C, then that cancels with that. So there's the 2 and the 1 plus C. Okay, so let's just double check. We did a case where C is equal to 2/5. So 1 plus 2/5 gives us 7/5, right? We'd have 2GH over 5/5 plus 2/5, yeah, 7/5. And 2 over 7/5 is the same as 10 over 7. Oh, and this is all square root. So, yeah, that's right. So we can just use this shortcut to get these last two. Why don't you take a moment and figure out what those last two results are going to be. V is equal to the square root of 2GH over 1 plus C, where C is the constant that comes in front of the mr squared. Okay, so 2/3 plus 3/3 would give us 5/3, and 2 over 5/3 is the same as 6/5, right? And that's the one, oh, I got this out of place, I'm sorry. This is the 6/5 GH, right? We did the hollow sphere and the solid sphere, my bad. So let's erase this, say that is in question. Okay, so I should have used 1/2 as the C. What a mess. Do-overs. Well, we got this part right. V is equal to the square root of 2GH over 1 plus C, but I should be using 1/2 as C. So 1 plus 1/2 gives me 3/2, and 2 over 3/2 would give me 4/3. So this is the square root of 4/3 GH, and then in the last one, C is equal to 1. So 1 plus 1, 2 over 1 plus 1. Oh, 2 over 2 gives us 1. Oh, we just get the square root of GH. All right, let's see. We'll grab a calculator and let's double check what all these values would be. 2, okay, I don't need to explain what 2 is equal to. 6/5 can be thought of as 1.2. We can substitute a 1 in front of the GH right here. So we've got 1, 1.2, 4/3. Actually, you don't need a calculator for that. 4/3 is 1.33. And, yeah, 2. We got that. So we got 1, 1.2, 1.33, 2. What's 10/7? That's the one we need a calculator for. 10/7 is about 1.43. Oh, so look, the way I listed them, I actually have them in order of first place finish to last place finish. The cart would win the race, the solid sphere would come in second, the solid disc would have the next highest speed and therefore reach the bottom in the least amount of time, followed by the hollow sphere and so on. So you can try it. If you can find somewhere in your house, maybe a soccer ball or a basketball, that'll be your hollow sphere. Maybe you have a billiard ball, that'll be your solid sphere. Maybe you've got a can of a can of cream of anything type soup, right? Because all that stuff is like a solid mass inside the can. Let's see, what could we do for a hollow? Maybe you've got something in a ring shape for your hollow cylinder. And race them all down the ramp and see if we've got that right. See if the solid sphere comes in first place, the solid cylinder comes in second place, the hollow sphere comes in third place, and then the ring or hoop comes in last. All right.